Okay, today we're going to explain the famous Ohm's law, which is V equals I times R. V as the voltage, I is the current, R is the resistance. Okay, first of all, we need to know about some other equations. The first equation that we have to know is F equals E times Q. Some books write it as F equals QE. And actually it comes from the Coulomb's law, which is pretty simple. It's based on experiments, nothing theoretical. Suppose that we have two charges named as Q1 and Q2, and there's a distance between them which is d, and Coulomb's law says that F, the force between them, it doesn't have to be, F shouldn't don't have to be through them. Q1's magnetic electric force does not have to be on Q1's electric force on Q2, doesn't have to be through Q1. It's the directions can change, but the law says that they are equal. By the way, electric force of Q1 on Q2 equals to electric force of Q2 on Q1. They are equal, and that's equal to, that is magnitude, is equal to Ke times Q1 times Q2 over d squared. So this is called Coulomb's law, and if you take out the d, I'm not explaining I'm not trying to prove those equations. If you do this d, if you put there, this is equal to electric field, but this is equal to electric force. Okay, so this is what you should know about Ohm's law to understand the concept. Now we're going to talk about current. What is current? Current is dq over dt. You may say, what is d? You don't have to worry about that. We can use delta as the change of current over unit time. Okay, this is I. So think about the cable. This is something like that, right? This is our cable. This is cross section of the cable, and we have some charge going on. Okay, this is area. Yeah, this is VD T. Well, let's say VT. This is okay. We should know some N, which is free electrons per cubic meter. So in our example, we are taking a copper cable which has N of copper is 10 to the 29 free electrons per cubic meter. Okay, this is N, and we have T. This is time between collisions, and that's equal to, T is equal to 3 times 10 to the minus 14 seconds. Okay, now we're going to put some basic equations. Now, we all know the Newton's second law. It's only applied on systems which has to have constant masses. So that is actually, F equals ma is actually for constant masses, because the real law, Newton's second law, is actually dp over dt. and P equals mV. So that's equal to d over dt times mv. Since m is constant, we take m out, so it's equal to d over dt v. So that is m times a, right? So that's Newton's second law. That's easy. So we know that F equals QE, right? And now from there, Newton's second law, mechanics, F equals ma. So we can equate them, okay? F equals QE equals ma. Instead of a, we know that a equals delta v over delta t. We write that as F equals QE, and that's equal to m times delta v over delta t. And instead of this, we say m times vd over t. We know what this t is, and we know that what vd, no, we don't know. Vd is drift velocity. Drift velocity. What's drift velocity? Drift velocity is the velocity of electrons between collisions, and we consider that as a constant velocity because we don't care about the acceleration between the collisions, since we show that t is so, it happens so fast, so we don't have to put acceleration in that equation. So we'll consider that as a constant velocity. So q times e equals m times vd over t. So what we do now, we say that from there, vd equals e times q times t over me. So okay, what we have from this equation is that vd, to drift velocity, is equal to q times e times t over m e. What does that mean? E is the mass of the electrons, q is the charge of the electrons, e is the electric field, t is the time between collisions. So we know that I equals to q over t. So I'm going to write q down is n times e times volume, and we're going to divide those to t, and this is equal to I. So what's that? We know that n is the free electrons and e is the charge of the electron. So we know how many electrons do we have here, and we know the charge of the electrons. So we know the charge and the volume, right? So if you multiply that with volume, we have the charge over volume times volume is the charge. So we have q, and if we divide that to t, we have I. So that holds, and from there we say, what's volume? Volume is vd times t times a, and we divide that to t. T's cancel out, n times e times, instead of vd, we put those things down. So n times e times q times e times t over me times a. So we know the no, we should have, no, it's okay, n times, and e and q are the same things. These are mass of the electrons, so we say ne squared times q, and we don't need q, we already said that is q times t times a over me. So we're going to say that R, resistance, what is resistance? We have a formula for resistance. We say that L over A times conductivity, or resistivity times L over A. Conductivity is 1 over resistivity. So what we have now, instead of E, because we know V equals to E times D, we can say E equals V over D, So we're going to say that E equals V over D times T times A over ME. So if we rewrite that equation again, we have this, and if we rearrange those the elements of our equation, we will have this. So what do we know? What do we know is we define the resistance as D over conductivity times A, or resistivity times D over A. So we know that conductivity and resistivity, the multiplication of conductivity and resistivity is 1, since they're non-proportional. So what is D over A? D over A is R times conductivity. So if we put that there, V equals to I times ME over NE squared times T times R times conductivity. We actually defined conductivity. I actually made it in a reverse way to make you understand that conductivity is equal to ME over NE squared times T. So you can get a grip of it. Conductivity is equal to this. So mass of our particle, number of particles in our volume, unit volume, the charge of our particle squared times the time between the collision of our particles equals to conductivity. So from there we have, it's actually reverse. Yeah, I'm sorry. This is the reverse of it. So conductivity is equal to NE squared T over ME. So V equals to I times 1 over conductivity times R times conductivity. What is this? What is this? V equals I times R. So that conductivity part is a little bit, someone just said, well, let's make an experiment. We say that this, like, if we increase the mass of our particle, our conductivity will go down because it is harder for our particles to move on. So it makes sense. The number of if the time between collisions goes down, the conductivity goes down, since it can't conduct. Think about it. If our particles can't transport the charge in a long time, surely conductivity will go down. So that makes sense. So that's where you have V equals I times R. Well, let's think about that. If we increase the temperature, what's going to happen? If we increase the temperature, the particles will collide faster than before. So what will happen is, if the temperature goes up, the time between collision goes down. And what happens is collision goes down. Collision doesn't go down, but the conductivity goes down. So look at the formula. If conductivity goes down, resistance goes up. So if you heat up a material, if you everything has a resistance. If you increase the temperature of a material, since the T goes down, the conductivity goes down. Since the conductivity goes down, resistance will go up. So increasing the temperature of a material will increase its resistance. That's how you explain Ohm's law. Thank you.